Good morning, everyone. Today we'll discuss transient analysis in electrical system. Okay, transient in electrical system. Okay, first we need to understand what do you mean by transient? What do you mean by this term transient? Okay, so basically, transient means if we say in very simple language, something is changing. Transient means something is changing. That means it is not fixed at some level. If we think about electrical system like voltage or current, so transient voltage or voltage means basically the voltage is changing. Okay, so and this something basically is energy level. Okay, so transient analysis in electrical system basically means we need to analyze how these energy level changes from one state to another state in electrical system. Okay, so next is why these transient occurs, the reason for transient. Okay, next is reason for transient. The reason for transient is as I have already mentioned that it is transient means something is changing. Something means here is energy level is changing. So transient is associated with energy. So obviously in electrical system where we have energy storage element, okay, where we have energy storage element, there we'll see these transient effect. Okay, so if we write in any electrical system where energy storage elements are present, there we will have transient. So what I'm saying, so this basically related with this energy. Okay, and electrical system energy storage element means energy storage element means energy storage element is inductor and capacitor. Inductor and capacitor. Okay, so in any electrical circuit where either inductor or capacitor or both inductor and capacitor present, there will have this transient analysis in electrical system. So next is why these energy storage element, why we have this transient, why not in energy um, dissipated means like resistor. If we have resistor, if you have only circuit where you have only resistor, there will be no transient. Okay, so point is if only resistance is present in a circuit, then there will be no transient. Keep this in mind. Okay, so transient will be there only if we have energy storage element like either inductor or capacitor. And why this transient occurred in this inductor capacitor? Because from very basic, I think we know that energy either in inductor or capacitor cannot change instantaneously. Okay, means we know that energy in inductor and capacitor cannot change instantaneously. Instantaneously. Okay, instantaneously. Okay, so cannot change is the inductor capacitor cannot change instantaneously. Why? Why these energy in inductor capacitor cannot change instantaneously? Okay, because we know the voltage current relationship between its inductor, মানে VI relation in inductor is V equal to L dt of I. Okay, in case of this inductor, and in case of and VI relation in capacitor is I equal to C into ddt of V, means V is voltage across capacitor, I is current flowing through capacitor, and something like this. Okay, this is, suppose this will be in short form. Right. This is small v. So this is the V. This is current. This is L. Similarly, in case of capacitor, this is I. This is V. This is C. Okay, and energy is half Li square. Similarly, in capacitor, energy is half CV square. So the transient will be there in inductor capacitor because energy cannot change instantaneously, means at zero instant. And as suppose there is a circuit, and as soon as we switch on the circuit, these circuits will take some time to redistribute the energy. Why? Because either we have in this circuit either inductor or capacitor. Now, if we see, L is constant here in case of inductor, and in case of capacitor, this suppose C is constant. So energy is inductor proportional to current. Now, if we see V equal to L di dt. Okay. Now, suppose if this energy needs to change instantaneously, so obviously this current need to change instantaneously. Now, if we look these equations very carefully, here we have ddt of I. That means this current di needs to be changed instantaneously. That means what does this di dt means? Di dt means change of current I2 minus I1 by suppose T2 minus one difference. Okay. So suppose, so this I2 minus I1 should be instantaneous, means this there will be no difference between T2 and T1. So if we say theoretically, so it needs to be 0. So if this current in case of inductor is changed instantaneously, then these term di dt become infinity. That means in inductor, if we want to change current instantaneously, means 0 time, we need an infinite voltage. We need infinite voltage. Okay, so that's why which is practically not possible to have any infinite voltage. Okay, so that's why current in an inductor cannot change instantaneously. That's why this energy in inductor cannot change instantaneously, it takes some time. The same concept applies for capacitor also. Energy of capacitor proportional to voltage, because C is constant. So if I suppose this voltage across capacitor needs to change instantaneously, so this dV dt will become infinity. This dV dt will become infinity. That means to change voltage across a capacitor instantaneously, we need a current of infinite value, which is practically not possible. So that's why voltage across a capacitor cannot change instantaneously. That's why energy in a capacitor cannot change instantaneously. It takes some time. So that's why this transient occurs only in inductor and capacitor. In a circuit where either inductor or capacitor, or both inductor and capacitor present. Okay, so if there is no inductor or no capacitor, there is no energy storage element, there will be no transient. Okay, keep this thing clear. And so basically transient means it is a change of state from one stable state to another stable state. And transient time means the time taken to change from one stable state to another stable state. That is called transient time. Okay, so transient is one stable state to, it is a path from one stable state to another stable state, and the time taken to reach from one stable state to another stable state is called transient time. Okay, so this is the basic. Thank you.